Hello friends, welcome to the session on digital electronics. In this session, we'll be discussing about methods of logic implementation. In this session, we will see what we mean by the logic implementation and what are the different methods that are available for implementing the given logical expression. So it is possible that whenever any logic expression is given to you, then you can implement it by using certain methods called as the methods of logic implementation. So in this session, we will discuss along with suitable examples, the different methods that are available for the logic implementation. Friends, as you know that you are viewing this session on my YouTube channel, and do subscribe to the channel so that you can study by sitting at your home only. You can study various topics of electronics and computer science. So let us start the session with the question what we mean by the different methods for the logic implementation. Whenever we have been given any truth table, then this truth table or the logic function need to be converted into the logic circuit. And whenever we want to convert the given truth table into the logic circuit, then we need to make the use of the logic gates. So whenever a given logic equation or expression is converted into the logic circuit, then that is to be called as the logic implementation. There are three commonly used methods for logic implementation. The first method is being called as the AOI logic, that is the AND or invert logic. The second is called as the NAND logic, and the third one is called as the NOR logic. So as its name indicates, AOI in this method will be using AND gate, will be using the combination of AND gates followed by a NOR gate. So when such combination of the logic gates is used for the implementation of the given logic expression, then that logic implementation is called as AOI logic. Another method is you can make the use of only NAND gates. We know that NAND gate is a universal gate, and therefore by using only NAND gate, it is possible that we can implement any given logic expression. So when only the NAND gates are used for the implementation of any given logic expression, then that is to be called as a NAND logic. Another method that is being used for the implementation is being called as a NOR logic. Like NAND gate, NOR gate is also a universal gate. It means that any given Boolean expression can be implemented by using only NOR gates. And whenever we make such combination of NOR gates to implement the given expression, then that is to be called as a NOR logic. So out of these three logic, it is being found that the AOI circuits are efficient as far as its CMOS technology is concerned. So when its implementation in the CMOS technology is concerned, it is being observed that these circuits will require less space, and also the circuits are more efficient than that of the NAND logic circuit and NOR logic circuits. Now, whenever we complement the AOI logic, then that logic is being called as the OR and invert logic, or it is also called as OAI logic, where the OR gates will precede a NAND gate. So let us discuss all these three methods of logic implementation along with certain suitable examples. So whenever we want to construct AOI logic circuit, then we need to follow certain steps. And these are to be called as the design steps. So suppose you have been given a SOP expression, then we know that the SOP expression will consist of min terms, and therefore we can implement each min term in the logic expression with the AND gate with the same number of input as the number of variables in the minterm. Say, for example, if the minterm consists of two variables such as A and B, then we will require the two input gate. But if the minterm consists of the three variables such as A, B, C, then we will require the three input gate. And if the minterms consist of the four variables such as A, B, C, and D, then we will require the four input gate. And then the output of the AND gate needs to be ORed, and then we will connect the NOT gate to the output of the OR gate. So in this way, we can implement the given logic expression by using the AOI logic. If necessary, the gates can be cascaded to create the gates with more inputs. So if there are more number of inputs, then it is possible that you can connect many other gates together so that you can handle many number of inputs. Let us consider a simple example. Suppose we have been given a SOP expression of this form: x is equal to AB complement of C plus complement of D into E. This is the SOP expression. Now, as far as this SOP expression is concerned, we know that we can construct the logic circuit by using AND gate and OR gate for the given SOP expression. So we will require the three input AND gate, of which the input will be A, B, C bar, and output will be A into B into C bar. The second AND gate will have the inputs D bar and E. Its output will be D bar into E. Then the outputs of both the AND gates are connected to the OR gate so that we can get the output X. Now, the same thing can also be implemented by using the AOI logic in this fashion. Now, the first two AND gates are kept as it is, and their inputs are also same. The first AND gate will have the input A, B, C bar. The second AND gate will have the input D bar and E. The output of both the AND gates are connected to a OR gate, and the output of the OR gate can be connected to a NOT gate. And when it is connected to the NOT gate, then you will find that you will obtain the AOI form of the expression, which is just nothing but the POS form of the expression. So one can easily observe that when the output of the SOP is being inverted, then we will get the AOI circuit, and it will lend itself to the POS form of the expression. POS, that will stand for product of sum form, and SOP, that will stand for sum of product form. It is possible that whenever we think of any AOI circuit, then this circuit can be implemented by using the SOP gates, and these gates can have the different forms. Say, for example, we can have a 2-2 AOI gate. So this 2-2 AOI gate will have the 4 input and only 1 output. So this can be a truth table for the 2-2 AOI gate, and the logic expression for this gate is Q is equal to A and B or C and D and the complement of the whole. So whenever we want to draw a 2-2 AOI symbol, then the 2-2 AOI symbol is being drawn in this fashion. So it is possible that the gates are available in the form of AOI gates, and by using these gates, you can implement any given logic expression. So as shown in this symbol, this AND gate has 2 inputs, another AND gate has 2 inputs, and output of both the AND gates is connected to a NOR gate. So there are certain ICs available. By making the use of these ICs, you can implement the logic circuit by using the AOI gates. Say, for example, we have an IC 74LS51, which consists of 3-3 AOI gate and 2-2 AOI gate. So AOI gates, as I told you, can be implemented by using the CMOS technology. Another logic that is being used is the NAND logic. In the NAND logic, whenever we have been given any SOP expression, then that expression can be implemented by using only NAND gates. For example, consider the SOP expression F is equal to X into Z plus W bar Y Z bar. Now we know that such expression can be implemented by using the two AND gates and one OR gate. The first AND gate will have the inputs X and Z. The second AND gate will have the input W bar, Y and Z bar. The output of both the AND gates are connected to the OR gate, of which the output is F. Now in NAND logic, it is possible that you can replace this circuit by using only NAND gates. So the inputs are same XZ to the first NAND gate. The second NAND gate will have the input W bar, Y, Z bar. The output of both the NAND gates is connected to another NAND gate, of which the output is F, which is just nothing but XZ plus W bar, Y, Z bar. So it is quite easy that whenever any SOP expression is given, then you can easily implement the SOP expression by using only NAND gates. And such a logic is being called as a NAND logic. So any AND OR logic circuit can be easily converted into the NAND logic circuit. Another logic that is being used for implementation of the expression is being called as a NOR logic. So in the NOR logic, it is possible that if you have been given any POS expression, then that POS expression can be implemented by using only NOR gates. For example, suppose we have been given POS expression X plus Z bar into W plus Y bar plus Z. Now, such a circuit can be drawn by using AND OR circuit. The first OR gate will have the input X and Z bar. The second OR gate will have the input W, Y bar and Z. Output of both the OR gates are connected to the AND gate, of which the output is the F. Now, such a circuit can be converted into the NOR logic circuit, where we can make the use of only NOR gates. The first NOR gate will have the inputs X and Z bar. The second NOR gate will have the inputs W, Y bar and Z. And the output of both the NOR gates are connected to the third NOR gate, of which the output is equal to F. So one can easily observe that by using the NOR logic, it is possible that we can convert the OR and logic circuit into the NOR logic circuit by using the NOR gates. So thank you friends for viewing the session. Hopefully you have understood the different methods for the logic implementation. Thank you all for viewing the session.